Hello and welcome back to the Tin Barn. I'm Pragmatic Lee, and today's video is another project for my nephew that I've done a couple of projects here in the Tin Barn for in the past. Most recently, a lot of you watched and commented and on the video of boring the hole in the intake manifold for a oil fill for his C60 Chevrolet flatbed truck. Well, he's got that motor running. He got the intake mounted on it, got the engine running, and he likes to jump between projects, which I really appreciate that in him. He doesn't get head over heels in one project. He'll work on one vehicle for a while and then go on to another one, then come back to the previous one and so forth. And right now he's working on a 1970 C10 Chevrolet. This is one he did an LS swap on some time back. As a matter of fact, probably before he married my niece, and I met him for the first time. But he's doing some more work on it now. In particular, he's modifying the steering. I think he said he was going from a steering box to a rack and pinions system. I don't understand or haven't really seen what all he's doing on that. But what he needs to do, he's taking the old 1970 components out and putting more modern stuff. I can't remember what he said these pieces were out of, but a much later model vehicle. And I really don't even know what these pieces do. I know they're part of the steering. But what he needs to do is couple that to these ball joints. This is a half 20, half-inch fine thread 20. This end is a 3/4 inch 16, which is a fine thread. One of these is left-hand threaded and the other one is right-handed. But we're going to take a piece of 1-inch hex, and he said he needs the pieces about 3.5 inches long. So we're going to take those pieces. Let me bring the camera in just a little bit and I'll show you what we're going to do with these. Alright, what we're going to do is cut a couple of pieces 3.5 inches long off of this 1-inch hex stock. And what we'll do is drill one end with a 29/64 tap drill, and we'll tap it half 20. On the other end, we'll drill 11/16 tap drill and tap that for a 3/4 16. The only difference between the two pieces is that one end, or the 3/4 end of one of the pieces, will be left-handed thread, whereas this first piece will be right-handed. Now I realize you get two pieces, right-hand thread on both ends means you can't roll the adjustment. Or if you roll the adjustment, it'll be both pieces going in and one going out, instead of a right hand and a left hand. They will come in or go out. But on these particular pieces, this rotates here. So he'll be able to set this 3/4 piece down here to the approximate length, and then do his final adjustment with the hex that's on here. The biggest thing we've got to do on this, or not the biggest, but one thing we've got to keep in mind and do, is that inside this remaining 2 inches that's in here, we need a void in there, so that when this piece threads in, we don't want to thread the full length 3/4 16. Our tap isn't even that long. We want about 3/4 of it tapped, and then the remainder of it be a void on the inside, so that this can go up in. To do that, we'll use the boring bar. But we're going to take this one step at a time for each of the two pieces, starting with cutting it off on the bandsaw. Okay, I'm at the vertical bandsaw now, and I've got the pieces marked or I've got each end marked at 3.5 inches. We're going to cut that just a little bit long. All right, we got 2 pieces to work with here. This third piece, we'll just put it back, send him back with it, send it back to him if he wants it. If not, we'll put it in the 10 born stock. But we're going to turn to the lathe now, and from probably this point on in the video, you will be looking at this project from an overhead perspective, overhead the lathe, because all the work will be done on the lathe. And then at the end, of course, we'll do a quick recap. Now, as I said, I've got you in an overhead view now. And what I'm going to do, first step here, is to face off one end, the saw cut end of both pieces. Now, round pieces in a 3-jaw chuck, I would never do what I'm going to do in this project, or would not do it the way I'm going to do it in this project. A round piece, practically impossible to take it out of a 3-jaw chuck, put it back in, and get it the same because of the inherent run out in a 3-jaw chuck. However, I'm using hex here. It's got flat sides. And so I've got one side of each of our 2 work pieces with red die chem on. I took some red marker and marked the number 1 jaw here on the lathe as well. So every time I take these out and put them back in, I'll put the same flat side to the same jaw, and it will be plenty close enough to be for a barrel for steering adjustment. So I'm gonna face off this end again, the saw cut end, and once I get that done, I'll go to the workbench and lay out the 3.5 inches on here and face the other end to that mark. Okay, I've got both pieces now face down to our 3.5 inch length. What I'm going to do next on each of the 2 pieces, I'm going to step drill this out to the 29/64, and I'll drill in there about an inch. We're going to thread 3/4 of an inch of it, but we'll do that after we mill out or bore out this void in here, and also get this to the 11/16. But right now, what we want to do on the 2 pieces is simply step drill out to 29/64. All right, that's got this end of this piece drilled to the tap drill size of 29/64. We will do just a little countersink right there. Now I'm going to take this piece out, do the same thing to the other work piece. All right, we've got both pieces, or one end of both pieces now, drilled for a 1/2-20 with the 29/64 tap drill. And we went in there well past our 3/4 that we're going to tap. But what we're going to do next, one piece at a time, we're going to drill in, step drill in again until we hit that void that we come into from the other end. We'll go with our small bit, and then I'll probably use the same 29/64, but then we'll go to 11/16, which is this size for the tap down here. We'll do that to both pieces. Now for this next step drill, we want to be sure we don't go in any more than the 2 3/4 inches, which that'll leave us as 3/4. We should run into where we drilled from the other side before we get that, but just in case, I'm going to mark the drill bit. Like I say, we should run into that void from the other side before we get to this point. But I just want to be sure we don't get into our tap size, tap dimension on the other end. Alright, that went into that void from the other end, which is what I expected. Alright, this is our tap drill for the 11/16. And again, I got it marked. I do not want to go past that depth. Yeah, she's pretty warm. Alright, so we have one end drilled out now, down to about 3/4 of an inch in from this other end. That'll give us plenty of area to tap for the 1/2 and what we'll need to do on this is come back in just a moment and bore out that void in the middle. But right now I'm going to get the other piece up to this stage. Alright, here's where we are so far. In this end we've got a 29/64, a little over 3/4 of an inch in. On this end we got 11/16, and it is drilled out to where it intersected this drill from this end. What we need to do now is this void that's in the center here. There's no problem with the 1/2 20 threads clearing once it passes this 3/4, but the 3/4 16, once it got to, we're going to tap about 3/4 of an way in. Even if we tap the full length of the tap, that may not be as long as the threads on the ball joint here. So what we need to do is clean out a void in between. And to do that, I'm going to use my boring bar. And from this edge to where we intersect the 3/4 from the other end is 2 3/4 inches. So I have my boring bar length set from here to the point to 3/4 of an inch. Now this point sticks out just maybe 100 thousandths beyond this. So what we're going to do is go in, touch off on this 11/16, and then just kind of plunge in, pull in until we bottom out. We just got to remember though to start at our 3/4 in. So the way I'm going to set that up, I'm going to touch the boring bar off. At this length right here, zero out the Z-axis on the DRO. Then I'm going to come in 3/4 of an inch. And I'm going to bump, I don't know if you can see it. Yeah, you can see it on camera. I'm going to bump the tailstock up to here. That way when I bring the carriage back, I can't mistakenly get into my 3/4 on this side, this end that's going to be threaded. So I'll lock the tailstock down right there. Now let's touch off. And also as a bit of an indicator here, there's a step on the boring bar that I can watch for as well. So let's touch off right here. We'll just do that by ear. And we're definitely going to get some squealing. So I'll zero out the x-axis. There's about 40 thousandths. And we'll feed that in until we touch off here. I don't like to have a boring bar sticking out that far, but I really don't have any other alternative here. And my next size up boring bar is too big to fit into that 11/16. Okay, come back up. And we'll continue this process until this edge of the boring bar right here is rubbing against our tap drill hole. All right, I've come back in now, so I should be clear of my tap drill area. Not sure if you'll be able to see this, but I'll take it out. And I can feel in here, just beyond that 3/4, there's a void, and I can see it, of course, down below. Now the double depth of thread for a 3/4 16 is about 65 thousandths. I just came in on the boring bar 115 thousandths, so I should have plenty of clearance in there. I'm going to do the same thing to the other piece. And then after that, we should be ready to do some actual tapping. All right, I think we're ready to tap now. And I hope nobody's disappointed that I'm using the tap instead of a single pointing it. But I got a 3/4 16. And my nephew had, well, I've got a right hand one, and my nephew had a left-handed. So I wish the tap had the center in the back of it, so I could put the tap guide in the chuck, in the drill chuck, but these have got a square end. The left-handed one actually does have a center in there. But we're going to tap this by hand. We've got everything set up straight here. Plenty of tap on it, or plenty of tap oil. And remember, this is only going to tap 3/4 of an inch in. I'll use the tailstock to keep pressure on it. And keep it running straight. Now I've got it started pretty good there. Break that chip. So I'm going to bring it up and see if I can start power tapping now. I'll turn my RPM way down. I'm in forward. And there we go. Put the lathe in reverse. Now let's take our right-handed ball joint and be sure that fits in. Very good, very happy with that. And of course we've gone in more than 3/4 of an inch now, so it's obvious we got relief on the inside. Now I'm going to take this 3/4 16 right hand tap and put it away right now so I don't accidentally pick it up in a minute and do the other one right-handed, because the other one gets to be left-handed. All right, I've got the 3/4 16, or yeah, 3/4 16 left-hand tap in now, and we'll start out the same way we did the right hand, but we'll go in the, of course, the opposite direction. All right, I'm going to put the lathe in reverse now. I'll come back a couple times and break that chip. Lathe is in reverse. Let's see. And that should be all the way in. As short as that tap is, I do not want to run it into that void and have to wrestle to get it back out. And if it sounds like I'm talking from experience, I did do a test piece with this tap and did that very thing, running in there too far. But we're good now. Now let's take our left-handed piece and be sure that works. Working fine. Okay, I just realized that I lost audio on a couple subsequent segments here, but all I did in those segments was turn the piece around after we had drilled and tapped for the uh, 3/4 16. Turned it around and drilled and tapped for the half 20. Did one end of each piece that way, and then tested to be sure the threads matched. And of course they did. Then the next thing I did was turn these ends down for 200 thousandths in, and just turn them down to where we will round. And what the purpose of that is going to be is that here's a barrel off of another linkage, but this part right here was turned down, and then we got a taper back in this direction, and that's what I want to do with these as well. So I turn both ends of both pieces down to the round. Let me find my calipers right quick. And we're going to call this the small diameter. And 1.035. And then the large diameter is going to be across the high points, 1.143. And we want to take about a 3/4 inch taper over here. So let's take those measurements over to the computer right quick and see what angle we need to set the compound. Okay, at the computer now, and of course we're running the machinist applets program, the taper calculator, and it tells us to enter any three. So the large diameter we measured is 1.143. Small diameter we wanted 1.035, and the length we wanted 0.75. That tells us we need to set our compound angle at 4 degrees. So we'll do that and turn the taper. Okay, the program said we needed to set the compound at 4 degrees. So that's what I've done. I've turned it this way. And we're going to start taking these points off, and it'll go approximately 3/4 of an inch taper up the length of the barrel. Now I'm not moving the carriage any at all here. As a matter of fact, I've got it locked down. All I'm doing is feeding in on the compound. Feeding in on the cross slide. Carriage is locked down. I'm feeding in on the cross slide each step and turning the compound, which is set at 4 degrees. All right, I just realized I was running out of travel on my compound. So I'll move the carriage back over and lock it down. All right, there we have a nice taper back on the on this end of the barrel. I will bring this back out. turn this piece around and do the other end. Alright, there's both ends of this barrel tapered off. I'm going to do both ends of the other one the same way. And then we're going to polish up, clean this die cam off, polish them up a little bit, and we'll do a quick little recap. Alright, we've got our two turnbuckles finished. Barrels for the turnbuckles, got them polished up just a little bit, taper on each end. As I said in the beginning of this video, this is going updating the steering on a 1970 C10 pickup that my nephew is working on. Hope you've enjoyed this video, but before I leave you, if you've been kind of eagle-eyed, you might have noticed this other project that's sitting on the workbench. Yes, this is a 6-inch rotary table, and I have indeed mounted a stepper motor to it. So stick with the channel. Upcoming videos, I'll show building this mount and what I think will be a practical use for this. But for now, take care, and I'll see you on the next video.